Hello, this is molecular geometry 1. We're going to look at the VSEPR model on how to determine the geometry of a molecule.
Molecular geometry is the three-dimensional arrangement of atoms in a molecule. The arrangement of atoms in a molecule affects the physical and chemical properties of a molecule. The question is how to predict the three-dimensional arrangement of atoms in a molecule. The answer involves an assumption that the electron pairs in the valence energy level repel one another. The valence energy level is called the valence shell. The valence shell holds electrons that are involved in bonding. In a polyatomic molecule, there are two or more bonds between the central atom and the surrounding atoms. The geometry that the polyatomic molecule assumes minimizes the valence shell electron repulsions. This study of molecular geometry is called the valence shell electron pair repulsion model. This is abbreviated as VSEPR model. Consider BeCl2. The total number of valence electrons is 2 plus 14 equals 16. The Lewis dot structure with all atoms having a formal charge of 0 is
Look at the central atom. A. All bonds from the central atom are called charge clouds. B. If there are any lone pairs of electrons on the central atom, then they are also considered as charge clouds.
Hence, in BeCl2 there are two charge clouds.
So remember that these are the two cloud charge. So just in case when you have a lone pair of electron, maybe somewhere here, that is if another example is given, that would be another electron cloud charge. That is what you're going to count as one. Whether it is double bond or triple bond in between them, it is still counted as one.
Rule. In a molecule, when there are two charge clouds around the central atom, the geometry of the molecule is linear. In a linear geometry, the bond angle from the central atom is 180 degrees. In general, for a molecule AB2, where A is the central atom, the geometry is linear. Consider C2H2. The total number of valence electrons is 8 plus 2 equals 10. The Lewis dot structure satisfying both the octet and duet rules, and both carbon atoms having a formal charge of 0 is Look at the carbon atom on the left-hand side. It has a single bond with hydrogen atom and a triple bond with the other carbon atom. Always consider a multiple bond as a single charge cloud. Hence, this carbon atom only has two charge clouds. The same argument holds for the right-hand side carbon atom. Thus, the molecular geometry of C2H2 is linear, with a bond angle of 180 degrees. Other molecules having this geometry are CO2, HCN, etc. Consider BF3. The total number of valence electrons is 3 plus 21 equals 24. The Lewis dot structure with all atoms having a formal charge of 0 is
Look at the central atom. A. All bonds from the central atom are called charge clouds. B. If there are any lone pairs of electrons on the central atom, then they are also considered as charge clouds.
hence in BF3 there are 3 charge clouds. Rule. In a molecule, when there are 3 charge clouds around the central atom, the arrangement of electron pairs is trigonal planar. In a trigonal planar structure, the bond angle from the central atom is 120 degrees. In general, for a molecule AB3, where A is the central atom, the structure is trigonal planar. Consider C2H4. The total number of valence electrons is 8 plus 4 equals 12. The Lewis dot structure, satisfying both the octet and duet rules, and both carbon atoms having a formal charge of 0, is Look at the carbon atom on the left-hand side. It has 2 single bonds with 2 hydrogen atoms and a double bond with the other carbon atom. Always consider a multiple bond as a single charge cloud. Hence, this carbon atom has only 3 charge clouds. The same argument holds for the right-hand side carbon atom. Thus, the molecular geometry of C2H4 is trigonal planar with a bond angle of 120 degrees. Another molecule having this geometry is SO3.
Now looking at this, you're considering this carbon. So you have 1, 2, and 3 charge clouds. So remember, this double bond is counted as 1. And when you look at the angle, it's like when you have something like this. This is 120, 120, 120. So the 3 angles will be 360, that go in a circle.
Consider CH4. The total number of valence electrons is 4 plus 4 equals 8. The Lewis dot structure, satisfying both the duet and octet rules, and the carbon atom having a formal charge of 0, is
Look at the central atom. A. All bonds from the central atom are called charge clouds. B. If there are any lone pairs of electrons on the central atom, then they are also considered as charge clouds.
hence in CH4 there are 4 charge clouds.
You can see all the 4 charge clouds. This is a 3D structure.
Rule. In a molecule, when there are 4 charge clouds around the central atom, the arrangement of electron pairs is tetrahedral. In a tetrahedral geometry, the bond angle from the central atom is 109.5 degrees. In general, for a molecule AB4, where A is the central atom, the molecular geometry is tetrahedral. Another molecule having this geometry is SiCl4. Consider NH3. The total number of valence electrons is 5 plus 3 equals 8. The Lewis dot structure, satisfying both the octet and duet rules, and nitrogen atom having a formal charge of 0, is
Look at the central atom. A. All bonds from the central atom are called charge clouds. B. If there are any lone pairs of electrons on the central atom, then they are also considered as charge clouds.
thus nitrogen atom has 4 charge clouds. The general formula for a molecule of this type would be AB3E. E represents a lone pair of electrons on the central atom A.
Remember that this has a lone pair of electron. That's why it has 4 charge clouds.
Rule. In a molecule, when there are 4 charge clouds around the central atom, the arrangement of electron pairs is tetrahedral. However, in 4 charge clouds, when there are 3 bonds and 1 lone pair, the molecular geometry is trigonal pyramidal. In trigonal pyramidal geometry, the bond angle for the central atom is a little less than 109.5 degrees. Consider H2O. The total number of valence electrons is 2 plus 6 equals 8. The Lewis dot structure, satisfying the octet and duet rules, and the oxygen atom having a formal charge of 0 is
Look at the central atom. A. All bonds from the central atom are called charge clouds. B. If there are any lone pairs of electrons on the central atom, then they are also considered as charge clouds.
thus the oxygen atom has 4 charge clouds. The general formula for a molecule of this type would be AB2E2. E represents the lone pair of electrons on the central atom A.
Remember when you see water molecule like this, the lone pair of electrons are also there. Okay. It can also be written this way. So this can explain the responsibilities, the reason why this is pushed down because of electron repulsion. All right. So these are the two lone pair of electrons. So it has 4 charge clouds. 1, 2, 3, 4.
Rule. In a molecule, when there are 4 charge clouds around the central atom, the arrangement of electron pairs is tetrahedral. However, in 4 charge clouds, when there are 2 bonds and 2 lone pairs, the molecular geometry is bent or V-shaped. In a bent or V-shaped geometry, the bond angle is less than 109.5 degrees. Other molecules having this geometry are OF2, SCl2, etc. Summary: AB4, 4, 4, 0, tetrahedral, tetrahedral. AB3E, 4, 3, 1, tetrahedral, trigonal pyramidal. AB2E2, 4, 2, 2, tetrahedral, bent or V-shaped. All these concepts can be applied in predicting the geometry of polyatomic ions.
All right, in summary, remember that the number of charge clouds equals to the sum of the number of bonds and number of lone pair of electrons. We have 4 charge clouds. Here you have 3 number of bonds with 1 lone pair of electron making 4. Here you have 4 charge clouds. So you have 2 number of bonds, 2 number of lone pair of electrons. And then one thing I want to clarify here is H2O and CO2, though they might not look alike, like, okay, because somebody might say, oh, this one has 2 oxygen, this one has 1 carbon, this one has 2 hydrogen, this one 1. So this is ratio 2 to 1, and this is ratio 1 to 2, that they are almost the same. No, this has a lone pair of electron. That is why it is bent. The geometry is bent. Molecular geometry is bent. But this one doesn't have a lone pair of electron. Carbon dioxide does not have lone pair of electron. That's why it's linear. All right? It's linear. It's quite different from H2O. So it's linear. Compared to it has lone pair of electron. This one doesn't have lone pair of electron because it has all the electron it needs. It has 4 on, 8 here, and then this one also has 1, 2, 3, 4 to make 8 when you draw the Lewis structure. All right, that's just a summary of VSEPR model of molecules with different geometry. Thank you. All right, let's test our understanding of the content. What you can do is just pause the video as you go along in order to take the assessment questions. Which of the following species is trigonal planar? Look at the options, pick your answer. Which of the following species is tetrahedral? Three, the bond angles in GeCl4 are. What is the shape of a molecule with the VESPR formula of AB3E? If a molecule has a central atom with 5 bonding pairs of electrons, single bonds, what is the shape of the molecule? What is the molecular shape of CO2? Which molecule is non-polar? Which molecule has a dipole moment equal to 0? What is the shape of PCl5? And what is the shape of ICl4 plus? So make sure you pause the video and answer those questions to check mastery of the contents. Okay, here are the answers to your questions. Which of the following species is trigonal planar? P, B, F, 3.
The shape of a molecule is determined by the number of charge clouds. Charge clouds are the bonds and or the lone pair of electrons on the central atom. For a molecule to have trigonal planar geometry, it must have 3 charge clouds and no lone pairs of electrons. The central atom in SF2 has 4 charge clouds, 2 bonds and 2 lone pairs. Therefore, its geometry is bent or V-shaped. ClO3- has 4 charge clouds, one of which is a lone pair of electrons. Therefore, it has a trigonal pyramidal geometry. SiH3- has 4 charge clouds, one of which is a lone pair of electrons. Therefore, it has a trigonal pyramidal geometry. BF3 has 3 charge clouds, as there are 3 bonds from the central atom. Therefore, it has a trigonal planar geometry. Hence, BF3 is the correct answer.
All right, those are the reasons for choosing option C. I'm going to go through all the questions like that so that you know the reason why the answers are not correct. So the following species is tetrahedral. SO4 2 minus. Let's listen to the explanation.
The shape of a molecule is determined by the number of charge clouds and/or the number of lone pairs of electrons around the central atom. Charge clouds are the bonds and/or the lone pair electrons attached to the central atom. In order for the molecule to have a tetrahedral geometry, it must have 4 charge clouds, that is, 4 bonds and no lone pairs of electrons. The central atom in SF2 has 4 electron clouds, 2 of which are lone pairs. Therefore, it is V-shaped or bent geometry. The central atom in C2H4 has 3 charge clouds and no lone pairs of electrons. Therefore, it has a trigonal planar geometry. The central atom in CO2 has 2 charge clouds, none of which are lone pairs of electrons. Therefore, it has a linear geometry. The central atom in SO4-2 has 4 charge clouds, none of which are lone pairs of electrons. Therefore, it has a tetrahedral geometry. Hence, SO4-2 is the correct answer.
The bond angles in GeCl4 are 109.5.
The central atom in GeCl4 has 4 bonds. Thus, Ge has 4 charge clouds. Therefore, GeCl4 has a tetrahedral shape. In order to obtain the lowest energy state, the atoms attached to the central atom move as far away as possible from the other peripheral atoms.
What is the shape of a molecule with the VESPR formula of AB3E? That will be trigonal pyramidal. Solution.
The arrangement of electrons around the central atom is tetrahedral. However, with 3 bonds and 1 lone pair of electrons, the molecular geometry is trigonal pyramidal.
If a molecule has a central atom with 5 bonding pairs of electrons, what is the shape of the molecule? 5 bonding pairs. That will be trigonal or pyramidal.
This structure will be what looks like 2 pyramids stacked base to base, hence the name bipyramidal. The 3 vertices make up its joint bases and what gives it the name trigonal. Therefore, the shape of the molecule is said to be trigonal bipyramidal.
What is the molecular shape of CO2? That's linear.
According to the Lewis dot structure, the carbon atom in CO2 has 2 double bonds. Thus, carbon atom has two charge clouds and the general formula is AB2. The farthest that the peripheral atoms could be from each other is 180 degrees. Hence, the molecular geometry of CO2 is linear.
Which molecule is non-polar? CCl4.
NO. Oxygen is more electronegative than nitrogen. Thus, the covalent bond between nitrogen atom and oxygen atom is a polar covalent bond. This polar covalent bond induces a dipole moment in the molecule, making the molecule polar. CCl4. Cl atom is more electronegative than C atom. The arrangement of atoms around carbon atom is tetrahedral. In this geometry, the dipole moments cancel out. Thus, carbon tetrachloride has no dipole moment, and hence it is non-polar.
Which molecule has a dipole moment equal to 0? BCl3 because they cancel out. So they are
In
balanced.
NO, O is more electronegative. Therefore, O has a partial negative charge and N has a partial positive charge. In PCl3, chlorine is more electronegative and consequently has a partial negative charge. Phosphorus, being less electronegative, has a partial positive charge. Because this molecule has a trigonal pyramidal geometry, the apex is positive while the base is negative. BCl3 is the only molecule in this problem without a dipole moment.
What is the shape of PCl5?
The shape of a molecule is determined by the number of charge clouds. Charge clouds are the bonds between the central atoms and its peripherals, as well as a lone pair electrons. A molecule with a central atom that has 5 bonds and no lone pairs of electrons has a trigonal bipyramidal molecular shape. This shape is formed because it has the largest bond angles for the molecule with 5 bonds. Therefore, PCl5 has a trigonal bipyramidal shape.
What is the shape of ICl4 plus? This is CCl.
Since the central atom iodine has 5 charge clouds, start out with a structure that has a trigonal bipyramidal shape. See that there are 2 pyramids, one right side up and the other upside down. However, there are 4 bonds and one lone pair of electrons associated with the central atom. This means that the shape is slightly different. The lone pair of electrons function in a similar fashion as atoms attached to the central atom. However, they are essentially invisible when trying to determine the name of the molecular structure. This molecular shape is called seesaw.
All right, those are the 10 questions I gave you, and these are the responses and the solutions. Please go ahead and review them, go over them as many times as you fit until you grasp the content knowledge. Thank you for listening. Thank you for watching. Have a nice day.